Have you ever stopped to think about how the internet actually works? Really works? We're going to peel back the curtain today on the invisible structure that makes our entire digital world possible. We're decoding the 7 layers of the OSI model. Let's get into it.
So let's start with a simple question. You type an email, you hit send, and almost instantly it's on a screen halfway around the world. How does that even happen? How does that data know where to go and how to put itself back together? Well, it's all thanks to a really brilliant system of organization. But to really appreciate it, you have to see what things were like before. Because, before we had this elegant system, computer networking was just a total mess. It was basically the Wild West, with everyone doing their own thing.
Back in the early days, network software was just one giant, sprawling program. Think of it like a massive ball of tangled yarn, where every single function was just knotted together with everything else. It was unbelievably complex, incredibly messy, and pretty much impossible to manage.
And this created some huge headaches. Since it was one big program, everything was connected. If one tiny thing went wrong, good luck finding the source of the problem. Testing was a total nightmare. And trying to add a new feature or make an improvement? Forget it. You'd probably break the whole system. There was no way networking could evolve like this. So, the brilliant minds of the time came up with a divide and conquer strategy. They said, okay, instead of one giant mess, let's break this huge task down into smaller, focused, manageable jobs. They called these jobs layers. And this whole idea of layered architecture is built on 3 really important concepts. First up is the service. So you can think of each layer as a specialist that has one specific job to do. Its service is basically the work it performs for the layer right above it. It's kind of like a relay race where each runner's only job is to get the baton to the next person in line. Next, we have the protocol. This one's a big deal. The protocol is the shared language. It's a set of rules that lets a layer on your computer talk to the same layer on someone else's computer. So layer 4 on my machine uses a protocol to talk directly to layer 4 on yours, making sure they understand each other perfectly, no matter what's happening on the other layers.
And finally, there's the interface. This is just the doorway between the layers on the same machine. It's the handoff point. It defines exactly how data gets passed down from, say, layer 7 to layer 6, and then from layer 6 to layer 5, keeping everything orderly and standardized inside the computer itself.
This whole idea of organizing networking into these layers with their own services, protocols, and interfaces, it was so logical and so powerful that it just had to be standardized so that any computer from any manufacturer could talk to any other computer in the world.
And the magic number they landed on for this new standard? 7. 7 distinct layers, 7 specific jobs, all working together in perfect harmony.
And it's called the Open Systems Interconnection Model, or as everyone calls it, the OSI model. It was created by the International Organization for Standardization, the ISO, way back in 1984, and it's been the fundamental blueprint for networking ever since. So, let's actually do this. Let's take that email we were talking about and follow its journey as it travels down all 7 of these layers, starting right at the very top where you click Send. Okay, our journey begins at the top, layer 7, the application layer. Now this is the only layer you, the user, ever really see. It's not your web browser or email app itself, but it's the protocol behind the app that talks to the network. Protocols like HTTP for the web, or in our case, SMTP for sending that email. It's the front door for your data. Once you hit send, your email gets passed down to layer 6, the presentation layer. You can think of this layer as the universal translator and the security guard. It makes sure the data is in a standard format that any computer can understand. It might compress it to make it smaller, and crucially, it encrypts it for security using things like SSL/TLS. This is what puts the S in HTTPS. Next up is layer 5, the session layer. Its job is to be the conversation manager. It opens up a communication channel, a session, between the two computers. It keeps that channel open for as long as it's needed, and then it closes it down neatly. It also creates checkpoints. You know when a huge download fails and you can resume it? That's layer 5 being your best friend.
Dropping down to layer 4, we meet the transport layer. This is quality control. It takes our big chunk of email data and chops it up into smaller pieces called segments. Then, it makes sure every single one of those segments gets to the other end correctly and in the right order. This is where the famous TCP protocol lives, ensuring reliable delivery for things that have to be perfect.
Now we're getting to the really cool part. Layer 3, the network layer. This is the global postal service for the entire internet. It takes those segments, puts them into envelopes called packets, and slaps a destination IP address on each one. Then it does its most important job, routing, figuring out the best possible path for that packet to take across the vast, complex web of networks to get where it's going.
Okay, so if Layer 3 is the global postal service, Layer 2, the data link layer, is the local mail carrier. Its job is much smaller. Just get the data from your computer to the very next device on your local network, like from your laptop to your Wi-Fi router. It uses local hardware addresses, called MAC addresses, and puts the data into something called frames to make this short little hop. And finally, we've hit the bottom. Layer 1, the physical layer. This is where all that digital information becomes a real physical thing. This layer takes all those ones and zeros and turns them into electrical signals zipping down an Ethernet cable, pulses of light in a fiber optic cable, or radio waves broadcasting from your Wi-Fi antenna. This is where data hits the road.
And then, on the other side of the world, the receiving computer just does this whole dance in reverse. The physical signals are picked up at Layer 1, rebuilt into frames at Layer 2, then packets at Layer 3, and so on, all the way back up the stack, until your email appears perfectly reconstructed on your friend's screen.
So that's the whole journey, top to bottom and back again. But so what? Why does this invisible 7-step process actually matter so much? What's the real power behind all this structure?
Well, the benefits are just immense. First, you get modularity. This means an engineer creating the next generation of Wi-Fi at Layer 1 doesn't need to know a single thing about how email works at Layer 7. It also makes things easy to modify. You can get a brand new Wi-Fi card without having to change your web browser. And finally, it's easy to test. When something breaks, you can figure out which layer is the problem and fix it without messing with anything else.
It really all boils down to this simple, beautiful idea. Each layer has a specific job to do, and it only needs to worry about talking to the layer directly above it and the layer directly below it. That's it. This brilliant simplicity is what allows the ridiculously complex global internet to actually be reliable and to keep growing and changing all the time.
And that brings us to a final thought. This model was designed in 1984. That's way before the cloud, before social media, before smart everything. So I'll leave you with this question. If you were designing a new layer for today's internet, a Layer 8, what problem would it solve? What would its job be? Something to chew on. Thanks for joining me.